I've been doing IPv6 deployment for over a decade now on a number of networks, so I have a number of lessons learned from various enterprise deployments and want to share some of that today. I've been doing this from a number of perspectives within the Department of Defense, both from a wide area ISP perspective on the Defense Research Engineering Network, and also within the Navy, looking at a lot of the security challenges and enterprise deployment in one large enterprise network there, but then also seeing what the rest of the federal government is doing from the perspective of my seat on the Federal IPv6 Task Force. So we'll be covering it from a number of perspectives, but also I'll deal with some things that might be very detailed for some of you over your head, other things very elementary that seems to be catching a lot of people off guard. So try to give a broad brush so you have something for everybody. So quick status, in the DoD there are multiple types of networks. There's the research engineering community, and a lot of those networks have been IPv6 enabled for quite some time. My own networks for over a decade. But the operational networks, those are the ones supporting military operations. If you're familiar with DoD networks, things like NIPRNet, SIPRNet, and so forth, those are not IPv6 enabled yet, although just a few months ago, they've got their final approvals to allow supporting IPv6 traffic. So we're hoping to see something turned on there soon. So most of my experience is on the research side, the engineering side, where we do modeling and simulation and high-performance computing. That all lives on the research side. In U.S. federal agencies, there is a new mandate that came out about a year ago that says all public-facing services in the federal government have to be IPv6 enabled by September of 2012. And that has driven a lot of activity, although there hasn't been much progress in the last year. So far, there are transition managers that have been assigned for every agency. So if you're part of the federal government, your agency has a transition manager. You should get to know who that person is. There's been a lot of planning, but no operational experience in many cases. And this is a big mistake in my opinion, because I see typical bureaucratic processes putting lots of people and spending a lot of money into working groups to come up with these massive plans to plan the entire thing out for the next 5 or 10 years. And these are people that have absolutely no operational experience with IPv6. And it's the old IPv4 thinking you see getting into that. Their addressing plans are a disaster. From what I've seen, luckily there's people starting to work on that. It's really a mess. And so we're trying to get them to just turn some things on sooner than later and to make some progress. There's been very little progress on IPv6 enabling anything. A little bit of activity in World IPv6 Day, but not much else, and they have a lot of problems just because of the bureaucracy. One example of one of the major problems is in the federal government, a lot of federal agencies get their connectivity, their internet connectivity, off of the GSA networks contract. It's a very large contract that has all the major carriers on that. In public, those carriers say they support IPv6 because it is required as part of the contract. The customers, when they go to them and say, I want IPv6, are told, don't ask for it, we're not quite ready yet. And so there's a real disconnect about what is true versus what they are saying in public. And when pressed, when we talk to those carriers, why are you doing this? You're saying one thing in public and another thing privately, and it's because, and they say, it's because we're required to support it as part of the GSA Networks contract, but we're really not ready yet. And so we don't want our customers asking for it, because if they ask for it and we can't deliver, then we have failed to deliver something we said we should have been able to deliver. And so we're trying to get that fixed. World IPv6 Day, a number of them cheated. They actually didn't turn anything on. They just had Akamai turn it on for them. And so they didn't really enable their networks, and that was kind of sad. It was a missed opportunity. And then there's a lot of confusion in this community over what does it mean to enable IPv6 as native IPv6. And what we really meant across all the federal agencies was just don't use tunneling and try to avoid translators and so forth. But many are interpreting it as have to turn off IPv4, and they're saying we can't do that. And we have to tell them, no, we didn't tell you you had to do that. You're misinterpreting what the terminology means. So just terminology issues are getting a lot of people tripped up. There is a website that you can follow to track deployment in the US government. And there's the website. It's really hard to find sometimes, but I tell people just to search for USG IPv6 status. And you can get charts to show progress and all the federal agencies, all the major websites, DNS servers, and so forth. But you can see it's not a very good story. There's a number of DNS servers that are v6 enabled, but websites, it's pretty much flat, almost down there at 0. You can see a little bit of a bump on World IPv6 Day and after that, but really it's a sad story across the federal government. But there's a major push to try to fix that by a year from now. So when we look at a lot of the enterprises and other organizations in the federal government, we ask, why aren't you deploying IPv6? What are your problems? And a lot of them say they lack incentive, they lack resources. There's other priorities like security. There's always some new security bug they have to fix or something else they have to buy. And so it all seems very overwhelming to them, and they don't know where to start in many cases. And they also say, there's no business case. There's no new thing that I can do once I get to IPv6, and so I can't get my CIO to agree to make this major investment to try to get to some new website, because there isn't something new I can get to. And so my answer to them is, if you haven't started yet, you're really too late, because it does take some time to deploy this, get experience, and find out what are the showstoppers in your infrastructure so you can get those fixed. If you do it right, it doesn't take a lot of additional resources. For federal agencies, there is a mandate, so you better get on with it. Don't waste a lot of time trying to develop this business case, because it's not a business case issue, it's a matter of survivability. You will not survive, the internet will not survive if you don't go to IPv6. And that's for businesses, it's for federal agencies, it's for everybody else. And don't be afraid to break some glass. A lot of people are just hesitant to turn things on and try it because they're worried about what's going to break. And in many cases we've observed, people start turning things on, it's like, wow, this really wasn't that hard, and things didn't break. And the things that did break, I was able to fix them really quickly. So why didn't I start earlier? And so message for all of you that haven't started yet, just start turning some things on. It really is easy, and things really don't break as bad as you think. Some of the lessons learned in the various deployments: addressing plans, huge problem. Everybody seems to make the same mistakes. Go native, dual stack. Start from the outside and work in. I've got more details on these slides in a minute. There's going to be a lot of challenges along the way, many surprises. You want to find those out earlier rather than later. So things like DNS updating, you can automate a lot of that. And if you start early and leverage tech refresh, it doesn't take a lot of resources. In the DREN and SPAYWAR case that I'll be talking about, no additional staffing, no additional funding, but we did it carefully over a period of time, and leverage tech refresh and other things to try to get IPv6 deployed. Okay, the story on addressing plans is that without sufficient operational experience with IPv6, you will get it wrong at first. I can almost guarantee that. I've seen it in 100% of the cases, even my own situation. It took me 3 times to get it right. And the problem is that a lot of the planners are hindered by IPv4 thinking. They may be IPv4 network experts. You might have been doing it for almost 30 years. And still, that is going to get in the way of developing your IPv6 address plan. People are just being too conservative, and they're thinking hosts instead of subnets, which is what you should be thinking of in the IPv6 sense. Typical mistakes: people suggesting other than /64 for standard subnet size. They didn't read the RFCs, 4291 and 5375, for example. If you're thinking of anything besides a /64 for subnets, go read those RFCs. And I've been in long, heated arguments with network experts in some of these federal agencies insisting that other than /64 is a good thing, or /64 is too wasteful. We have got to get them beyond that thinking. It's just a perception, a perspective that we have to get over. A lot of people are saying, I can't give small sites a /48, that's just too wasteful. Or point-to-point links, /64 is too wasteful. If you have that mindset, if that ever enters your mind that you think that is being wasteful, then you have not made the leap to the IPv6 world. And so that is something you need to work on in your own mind as you develop an addressing plan. A lot of them are still working on the request up instead of pre-allocate down approach. As I was reviewing some of the plans in the Navy and other places in the federal government, I see groups saying, just like IPv4, you need to justify how much address space you need, and then we'll allocate just the amount that you need for your particular enclave or site or project or whatever. And when I heard that presented about a month ago at one of the working group meetings, I said, why are you doing that? I can tell you what the answer is. Every site gets a /48. And it's just, no, you have to justify it, is the answer. Just like IPv4, we can't be wasteful. No, the answer is /48. That's what the site gets. Oh, people just can't get over that. And so that's what you're up against in many cases. After operational experience, here's what you realize. You never have to grow subnets, so you don't need to accommodate that situation, like in the IPv4 days where your /24 might be not quite enough and you have to increase it. If you don't use /64s, you can't do stateless address auto configuration, you can't do DHCPv6, you can't do multicast with embedded RP, some of the mobility things don't work, and on and on and on. /64 is the right answer. Here's a huge opportunity to align addressing with your security topology, and you can simplify your ACLs. We've seen cases where in routers people have hundreds of lines of ACLs. Once they get their IPv6 addressing plan right, one line, because they've blocked everything in large blocks that make sense. You can better align subnetting and aggregation with your existing topology. You realize it's a bad idea to embed IPv4 addresses in IPv6. A lot of people make that mistake, thinking it's administratively easier where it's actually administratively harder. You come to learn that every interface has multiple IPv6 addresses. People with the IPv4 mindset think a host has an IPv4 address. That's different for IPv6. Every interface has multiple addresses. Internal aggregation is not as important as you initially thought. You want to aggregate up at your ISP level. And you can do a lot of pre-allocation. Within DREN, all customers came up with a plan. So for an ISP, we pre-allocated all addresses to all existing customers in one fell swoop rather than wait for people to ask for it. Okay, on going native, native IPv6 means don't use tunnels. I mentioned that earlier. A lot of people are getting tripped up over that in the federal government. And we're telling everyone, please use dual stack as the translation mechanism. You can, as a transition mechanism. You can use translators in the interim, but that's not a long-term goal. But some people thinking it is the long-term solution, but it's not. Starting outside and work inwards, again, a lot of people in the government are making this mistake. They're taking their internal networks inside the firewall, their internal enclaves, making them IPv6 enabled, and they realize very quickly that they can't, things are timing out. It's because it's trying to do DNS, gets a quad A record, tries to connect to that over the internet, and it's not going to work. And so we tell people, you start from the outside and you work in. You get your ISP, dual stack, then you work with your public-facing services, your DMZ, and then work inside. Much better way. We have, over the years, experienced a lot of challenges and bugs. It's a lot better than it used to be. In the old days, you have to build a special version of the operating system for every OS, and that was very time-consuming, or you had to run beta code in your routers. Today, every modern OS has IPv6 built in. Most of them have it turned on by default. Every mainstream router, switch vendor has IPv6, and so that's not a problem. But you'll run into various bugs, either at the application level, missing features, and so forth. And I'm not going to go through all of these today, but I'm just giving you a sense of the type of problems that are out there, because these are the surprises that you can never anticipate. But in your applications, in your systems, they are things you will run into. You want to discover them early because you need to be able to tell your vendor to fix some of these issues. In many cases, it turns into a feature request, and the turnaround on some of those is up to 18 months, sometimes a couple of years. And so you don't want to be dead in the water for a couple of years while you're waiting for some of these features. Our goal in my own organization is to discover these as quickly as possible to get the vendors to fix them so that by the time the rest of the world gets around to deploying IPv6, most of the major issues will be resolved. So hopefully that'll help you all as you're doing your own deployments. Keeping DNS updated has been a problem for a lot of folks because as they deploy IPv6, they want to update DNS. They try to type in the PTR records and the quad A records in DNS. They're much longer, they're harder to type, prone to mistakes, and so you realize very quickly you don't want to do that, not like in IPv4. And so we've looked for ways to automate it. The obvious thing would be use something like DHCPv6, have it do DNS update. The problem is that most clients, at least in our environment, don't have DHCPv6 support. Mac OS X did not have it until Lion that just came out recently. A lot of our systems are still Windows XP. Not everybody is on Windows 7 yet, and so forth. And so they have no DHCPv6 client, so it's not worth deploying DHCPv6 services to solve that problem. So what we did is built an auto-update tool, and this is really fairly simple to build. You can do it with some Perl scripting or other scripts. And basically what you do is you connect all the routers on a regular basis, like every 10, 15 minutes or something like that. You dump the neighbor discovery table in the ARP cache, and you do a join, like a database join, to determine the mapping from the IPv4 address to the IPv6 address that goes per particular machine. You can do a DNS reverse query to look up the PTR record for the IPv4 address, and from that determine what should go in DNS for the IPv6 address, and you can just totally automate it and jam it right in. Works great, totally automated, it's hands-off, so if you're doing IPv4 DNS, you can get IPv6 DNS for free. There's some issues like when you talk to the routers, what is the MIB that you have to use to dump the neighbor discovery table, and a lot of vendors are doing it in various different ways. The right way to do it is a new unified MIB. RFC 4293 describes it, and a lot of vendors aren't supporting that yet. And so we're pushing hard to get full support for that. So now you have to build connectors for every different type of router that you use to use a tool like this. And it doesn't have to be costly to do this deployment. I mentioned earlier that we did it with no additional staffing, no additional funding, and if you use Tech Refresh, when you're doing a major switch upgrade, a major router upgrade, or building a new application, just make sure IPv6 is included as part of the procurement. Get guarantees from your vendors that IPv6 will be fully supported, and get it in writing so that if they don't support it, that you can call them on it and get them to fix it. We've seen cases where vendors said, yes, we will support it. What they meant was it was IPv6 capable, and that was some software someday might support it. And when we got it in writing, we insisted that they provide it, and when they found that their hardware didn't support it, that was good enough to actually make them give us new hardware to support it. So it's important to get it in writing. If you're in the federal government and you have to meet the 2012 deadline, if you haven't started yet, you're too late. So you need to scramble to start your deployment now and quickly so you can discover those showstoppers, get the workarounds, and meet the deadlines. Okay, I'm going to switch to my world a little bit, which is DREN and SPAYWAR. DREN is the Defense Research Engineering Network, which is the ISP for the DoD research community, which is separate from that operational community I described earlier. And then SPAYWAR is part of the U.S. Navy that does a lot of the IT services and acquisitions for the U.S. Navy. It operates its own separate research, development, test, and evaluation network. It's a wide area, over a dozen campuses. It is a customer of DREN, so DREN is the ISP for SPAYWAR among many others. SPAYWAR is and predecessor organization was one of the internet pioneers back in the early ARPANET days and running some of the original nodes on the ARPANET. So long experience, was involved in transitioning from NCP to IPv4 back in the early 80s, and so this is the second time around for us. In DREN and SPAYWAR, here's how we started over the years. Some of this started way back over 10 years ago. We started with a WAN and then worked on the local area networks, the wireless networks, basically getting the underlying infrastructure dual stacked. And then we started with the services, like all the authentication services, DNS, NTP, SMTP, Radius, LDAP, Kerberos, making everything dual stack, but doing it on the production infrastructure, not test bed. This is the real production infrastructure. Then we did the public-facing services, DNS, mail exchangers, the web, NTP, and so forth. And then we get to the hard part, the security stack. For a long time, the security components were not ready. The firewalls, intrusion prevention systems, IDSs, and so forth. In a lot of those cases, we had to roll our own until the vendors supported it. And then after we got that working, a lot of the internal security services, like Windows Update, we run McAfee EPO within DoD, it's mandated within DoD. Getting all of that working over IPv6 was a bit of a challenge, but we have that all working now. We made a push to have all servers, all desktops, all laptops, everything on the network in the enterprise fully dual stacked, and we did achieve that over the last year or so. We also started tackling the back-end services such as storage, NFS, CIFS servers and so forth, NetApp appliances. We got all of that IPv6 enabled. Interesting thing, we noticed that a lot of the clients, even when they were v6 enabled and the servers were v6 enabled, weren't actually using IPv6 transport. And that was because a lot of the older clients, Windows XP, for example, Mac, Solaris, some of the older ones, didn't have IPv6 client support to be able to talk to the services. So it's only the more modern operating systems that support this. And then network management, I'm going to go into some more detail because that's one of our current initiatives. But if you look at Mark Pryor's IPv6 status site, DREN and SPAYWAR were the first ones to go all green. So we've been doing this for a while. The major issues for us in this deployment today is lack of feature parity, vendors are not eating their own dog food, rogue router announcements, advertisements, privacy addresses, Mac OS X 10.6, and network management. So the lack of feature parity issue is a long-standing problem where when you buy a product from a vendor, say a router, a switch, or anything else, you expect to have a certain feature set. And when you start turning on IPv6, you find out that a whole lot of the features are not supported in IPv6 mode. And so when you have to deploy this in your network and you want IPv6 to work and support IPv6 connectivity, you have to do a lot of engineering workarounds to get around all the missing features. You couldn't do what you did before in IPv4. And so we've been pressing hard on the vendors saying we do need feature parity. Whatever your product does in IPv4, we need the equivalent to be able to operate in IPv6. None of them do it yet. And until we achieve this, then IPv6 is something less than IPv4. It does not have the same set of features, the same set of capabilities, and so this is a serious limitation that we need to get fixed. So we're pressing your vendors to do that. Privacy addresses is another killer in the enterprise environment. It's just incompatible with a lot of the policy, doctrine, procedures, and so forth that we find in the government and in other places. For example, we need logging, forensics, DNS stability, ACLs, and that really dictates a very stable address environment. One address that is always the same, registered in DNS, you can identify who the person is. But this is kind of the opposite of the v6 world, where they have temporary addresses or random identifiers for privacy purposes, as documented in RFC 4941. And it's enabled by default in Windows since XP and all through the latest operating systems, which for us breaks plug and play, which is one of the great features of IPv6, because now we have to visit every Windows machine and turn it off, go to the registry settings, disable temporary addresses, and disable the privacy settings, which doesn't scale very well, as you can imagine. And then Mac OS X Lion came out, it has privacy addresses. If you look at the Ubuntu mailing list, they're going to start doing privacy addresses. So it looks like a losing battle to us. We're swimming upstream and not going to be able to solve this. We looked at ways, is there a bit we can sit in the network that says, this is an enterprise network, don't do privacy? And so we looked at trying to get that through the IETF and was not very successful. So what if we have to live with it? If it's a losing battle, we have to live with it. What are we going to have to change in terms of our doctrine within DoD and the federal government? Like I said, we did come up with an internet draft, a technical solution, but that did not go over very well because the privacy advocates are very strong. And there would be ways to spoof this, and so it's not perfect. And so we've debated the topic in a lot of forums and are looking at, okay, what would it mean if we just said, if you can't beat them, join them. Let's try to live with these privacy addresses. So what we did is we created a separate subnet internetwork, put a few dozen machines over there of various operating systems, and are getting people to live with the privacy addresses in the enterprise environment to see what breaks. But we have to do things like keep track of all mapping of IPv6 addresses to MAC addresses over a period of time and keep it in a forever database. Because now, whenever there's a security incident or we have law enforcement looking into an issue or whatever, we can't just do a grep on an IPv6 address through all the logs, for example. No, we have to set it or check it against some kind of a correlation engine which verifies what the address is over time for a particular machine. What a pain. And so that's the biggest issue for us, is this database plus the correlation tools we're going to have to build in order to do any kind of forensics or any kind of tracking of a particular address over time as a result of an incident. Vendors not eating their own dog food. This has been a major issue for us, because when we would find out that some feature was missing or something in IPv6 didn't work from a particular vendor, we would say, how on earth did this miss your QA? Why didn't you discover this in your own network? And what we found was, when we asked them, the vendors, that, they would say, well, we don't use IPv6 in our networks. It's you guys that are asking for it. We just build it and give it to you. And then we asked, well, what about at least QA? And they said, well, we QA IPv4 stuff really well, but our QA for v6 is really not that mature yet, so we aren't testing everything. So the vendors aren't using it. We're having to discover all the bugs, which is a problem for us. And so we're trying to get them to fix that. Even trying to get them to v6 enable their public-facing services has been really hard, and we've been pressing hard. It's improving a little bit. Brocade finally last year did v6 enable their services. And to show the lesson learned from that is, after they did it, after we pressed them many years and they resisted and said how hard it was, in the end, the response to us was, wow, it really wasn't nearly as hard as we thought. And when we used our own products to do this, we found problems. And so we wouldn't have discovered this otherwise. So it was a good thing. We're glad we did it. And I wish some of the other vendors would do the same. They're trying, but it's still a pretty sad story. Rogue router advertisements. This is a real problem. The situation is documented in RFC 6104. You can go read about it. But basically, the issue is Windows systems with internet connection sharing turned on will become a rogue router and will send out router advertisements saying, I'm your default route to get to the network. So everybody else on that subnet, if they're doing v6, will have a 50-50 chance of using the correct router or using the rogue router. And so you have to detect this and block it. And the right answer is something called RA Guard, but none of the switch vendors, or very few of them, are implementing that yet. So the workaround is you set the router preference to high, and it's an easy setting in most routers. And that workaround is described in RFC 4191. Unfortunately, it doesn't work in Junos. So if you're a Juniper customer, you're sort of stuck and not able to solve that. We have other tools we've developed in our environment to detect and solve this and as well. So we're in better shape now, but this is something everybody is going to run into. But if you're buying new switch hardware, be sure to ask your vendor for RA Guard. That's the solution. Network management. So we asked, can we do network management over IPv6? Some people, this is a real pet peeve. I know for Vint Cerf, it's a pet peeve. He keeps asking about this. And so we said, well, let's see if we can try this. We'll do all of our network management over IPv6. And we've been working on this for years. And we find showstopper after showstopper and go through year or 2 year cycles with vendors to do feature requests. Then we find the next set of bugs, and it's been going on for a long time. We think we're pretty close. We think by December we'll be actually able to turn off IPv4 on our management LANs. Some of the status, at one of our sites with over 500 switches, we've turned off all IPv4 configuration. Routers, there's a few of them that are waiting for some bug fixes. We're very close. There's our monitoring tool. This is the thing that switches the like span ports or monitor ports into various sensors and so forth. We were looking at a product from a company called Inui, looked great, everybody loved it, did not support IPv6. And so we started looking around, found a competitor, Gigamon. They did support IPv6. That is the one we bought. I mentioned this because if you're a vendor and you don't support IPv6, you will lose business. Here's a case where one company lost to another just because they did not support IPv6. Same with UPSs. We were swapping out all of our UPSs, doing a tech refresh, looked at all the vendors. We said we want to manage over IPv6. Only one did it, APC, so the other vendors all lost. So another example of you will lose business if you don't support IPv6. So it's a case of business survival and that you need to support IPv6. And so we're continuing to move along, work with the vendor to fix the missing pieces, and hope to remove all IPv4 from the management networks, hopefully in December. Remaining issue, lack of that unified MIB support, RFC 4293, in many products. I have a picture of it, here's some mainstream vendors you might be familiar with, Cisco, Brocade, Juniper, Alcatel, Lucent. And the scorecard was a sea of red even just a year or so ago. Even about a year ago, Cisco was the worst, but once we tried release 12.258 SE1, it's looking much better. About the only thing they don't support is flow export over IPv6. Brocade supports almost everything, but not in every product, and so they have a number of cases where it's missing. Juniper, not so good. They don't support the unified MIB. They can't do flow export over IPv6, and LLDP is not supported for IPv6. Alcatel-Lucent looks pretty good, except also doesn't support flow export coming in a year. And for some reason, they don't do SSH over v6, but should be coming out next year. We also recently reviewed A10. Earlier software releases looked really bad. Latest software releases, they looked really good. Except for the flow issue, they don't support flow at all, so that was sort of not applicable, but they're looking pretty good. And so we're doing this a lot with vendors. Bring your gear in, we'll kick the tires, because that's the best way to find out if they really do support IPv6. Some quick notes on World IPv6 Day. For us, there's really nothing new to do for World IPv6 Day, because every day is IPv6 Day for us. We've been running this for years. But what was different for us is we wondered, what does this look like from an enterprise perspective where all clients or users are dual stack? Because World v6 Day was really focused on public web servers and getting your public infrastructure v6 enabled, so it was a service push. We looked at it from a client push saying, or client pull, saying, hey, if the world went to v6, what it would look like for us, what would be different? And so we had a lot of monitors set up to try to figure out what would change when 400 some odd ISPs and companies and content providers turned on v6. Over time, just to give you some history, when we were first doing IPv6, before Google did whitelisting or anything like that, our traffic to the internet, about 1% of it was IPv6. When we became whitelisted with Google, so that all our Google traffic was over v6, we jumped to 2.5% of our internet traffic was IPv6. When YouTube became v6 enabled in late January of 2010, suddenly we jumped up to 10% of our traffic was IPv6 to the internet. On World IPv6 Day, we peaked at 68%. Now that wasn't totally because of new servers out there doing v6, it was also because of some internal testing, people trying to get to the various v6 enabled websites, but it was fairly significant for us. And as we built a tool to plot and compute in real time what the percentage was, because this percentage was very interesting. And what we noticed was that we were actually peaking around 30% since World v6 Day. 30% of our traffic to the internet was v6. But it was much higher during the day than after hours. And so we really wondered about that and looked at our traffic to try to explain why. And the issue is that during the day, we have clients getting to the internet, hitting v6 websites, hitting YouTube, hitting other interesting things, and that really drives up the v6 traffic. At night, we have Oracle doing database synchronization, we have systems doing backups, and a lot of those type of processes and applications don't support v6 yet. So it was dominated by lots of v4 traffic at night. And so very low v6 percentages, but during the day, we're hitting 30%. So how does this average, like over days, weeks, or months? We plotted that as well. If we look at hourly averages over like the past week, we're hitting well above 20% in some cases over hourly averages. And across a month, the daily averages, sometimes we're hitting 15%, even with that night traffic that's mostly v4 dominated. So we're starting to see a fairly significant amount of traffic. And I bring this up because if you read a lot of press, they'll talk about, oh, the internet, it's only like 0.1% v6 traffic. But that's because there's a small percentage of the services that are v6 enabled, and most sites only have a few clients that are v6 enabled. If you're at 100%, you will see numbers like this. So, some other observations with World v6 Day. DoD, you would read that in the press that they participated and they had like 3 websites that were v6 enabled. They were one of those that just said, well, we'll let Akamai do it, and they actually didn't do anything at all. So totally missed opportunity, very sad. Still haven't turned on any v6 within the DoD operational networks, i.e. NIPRDET. NIST, there were 3 major failures on World IPv6 Day. Juniper DNS, which had nothing to do with IPv6, I'm told. Level 3, had a problem with one of their either websites, I think, and NIST, their website. Now, NIST is the one in U.S. government that's pressing with the USGV6 profile, a lot of publicity, the status website, and so forth. Yet NIST's own website failed on World IPv6 Day. And so when I asked them about it, I said, come on, guys, this is very bad from a reputation perspective. You failed. What went wrong? And in NIST, the IPv6 proponents said, we don't control our corporate website. That's another group. Typical problem in a lot of bureaucracies. They didn't know anything about IPv6, but what they did on the day before, they cloned the website, turned on IPv6, announced the Quad A address, and of course it was a major failure. No planning, they didn't know what they were doing. They had planned to do it as a throwaway anyway, but that's why they failed. Another observation, protocol proxies and translators. We see a lot of that starting to happen because people think it's the easy way. We're trying to figure out how to make sure they are only temporary. We want to get to native v6 end-to-end within the federal government. That is the goal. Avoid NAT, avoid translators, avoid tunneling. And then what's next? You already heard some folks mention maybe a World IPv6 Day or a week, thinking about maybe June timeframe. There has been a little discussion of, on the 30th anniversary of when NCP was turned off and it was IPv4 only, which was January 1 of 1983, the 30th anniversary would be January 1 of 2013. Wouldn't it be cool if we had some milestone and could actually declare the public internet as IPv6 ready or enabled or something like that? And so hopefully we can have some kind of a goal like that. In the interest of time, I'm going to pass by the do's and don'ts. Also, people ask me, does IPv6 has any benefit today? I mean, you're telling all this bad news about what IPv6 isn't. And actually, there is some good news that you will discover after you deploy it. With addressing, you can better map subnets to reality. You can align with security topology, which simplifies your ACLs. You don't have to worry about growing subnets anymore. You have auto-configuration or plug-and-play. You have a universal subnet size, no surprises, no operator confusion, no bit math. Just a lot easier to manage your addressing within your network. You have shorter addresses in some cases. If you do some interesting things with ULA addresses on your private internal networks, you can do some really cool things. And at home, you'll have multiple subnets rather than a single IP that you have to NAT. So that'll be really great. Also, multicast is far simpler in v6 than it is in v4. You have embedded RP, which is way cool as a way to pass around the RP and the group addresses. And also, there's no MSDP, which is a horrible protocol, and we're glad it's gone in v6. So there's some things that just get a lot better. Is there a killer app that is a major incentive for v6? No, there isn't one. But it's the internet itself that is the killer app. The internet cannot survive without IPv6, and that's why it's so important to deploy it sooner than later. The IPv4 internet is going to start crumbling here fairly soon as we see fragmentation, larger router tables, parts of the network segmented, with all the NATs that are going in, there are applications that are going to break. Fairly soon, I think the v4 internet is going to become more and more fragile, and so v6 is going to be the savior for that. Some final thoughts. Really the main point is look for a good vendor support, feature parity, and press your vendors. Example of one of the things we do in our organization, and I have the secretaries trained, everybody else trained, if some vendor comes to our door and wants to sell us something, some salesman, wants to set up a meeting or whatever, first thing we ask them, do you fully support IPv6? Of course, they all say yes. Then we say, okay, let me try to connect to your website over IPv6. Ooh, I can't get to your website. Why don't you go fix that first, and then come back and we'll talk. It's a great filter because it weeds out the ones who are serious from the ones who don't know what they're talking about. I would recommend you do the same. It is very helpful. So hopefully that gives you some interesting things to think about as you deploy it in your own environments, and that's all I have.